Hello, my name's Julian Edgar and I'm the author of the book Car Electrical and Electronic Systems. What I want to do in today's video is talk about using solid state relays, SSRs. Here's an example of a solid state relay, one that can be used in car electrical systems. Now that's an important first point. Many of solid state relays are sold for use on mains voltages and they won't work in a car system. So when you're selecting a solid state relay, make sure you get a DC-DC design, DC on both the input and the output. Another thing to keep in mind when you're selecting a solid state relay is it needs to be rated for the required current. Now, solid state relays have got two ratings for current. One is their continuous current supply and one is their gulp rating or surge rating. And that's important because if you're switching something like a fan or a pump, they'll always take a big gulp of current when they first switch on. So make sure you specify the relay for those two things, both the gulp current, the surge current and the continuous current. And just before I leave current, a lot of solid state relays will need to have a heatsink if they're running at their rated current. You can buy heat sinks that are designed to screw straight onto a solid state relay, so they're easy to source. Now let's talk about wiring. How do you wire a solid state relay? That's important because it's different to a mechanical relay. A mechanical relay with a coil and with contacts that get pulled across, that's a different type of relay. In a solid state relay, there's just a big switching transistor, no moving parts, and that's one of the huge advantages of solid state relays. But how do you wire them up? Well, I've got a picture here of a relay, a solid state relay, and it's got an input side, that's the side that you switch, and it's got an output side that drives the load. Now, look how both the input and the output are polarized. They've got pluses and minuses. So how would we wire this up to operate a load? Maybe from a little switch. Well, let's connect that negative to ground. It's on the input side, and let's run this to a switch that then runs to 12 volts. Now, it doesn't actually have to be 12 volts, and that's important. Solid state relays will typically work between, say, 3 and 32 volts on their input. So you can use a 5 volt supply if you've got one coming out of the ECU or something of that sort to actually control a solid state relay. Having said that, in car use, you usually will be using battery voltage. So when we close that switch, battery voltage flows through to the input, to the plus side, and then the other side, the negative side, is grounded. Now, what about on the load side? Well, let's feed this to battery voltage. Battery voltage comes into the plus, and then let's put the load, here's your load, on the output side here. So 12 volts comes through, plus feeds out battery voltage to the load, which is then grounded. Now, that can get a bit confusing, because if this load is polarized, there'll be a plus there, even though it's connected to the minus there. You've got to think it's actually being connected to the battery on the other side of the relay. So you can see it's not hard to wire up a solid state relay, but you just can't go about it unthinkingly. I mean, with a mechanical relay, you just basically connect things any way around and it will still work, but in this case, it won't. Now, let's talk about a couple more advantages of solid state relays. I said they've got no contacts, so they don't wear out. If you're switching high currents and you're switching them often, then a solid state relay is a really good way of doing it. In one of my cars, I've fitted a custom air suspension system, and I'm using a solid state relay to turn the compressor on and off. There's a pressure switch which monitors the pressure in the volume in the tank, and if that pressure is low, the pressure switch clicks over, it turns on the solid state relay, so there's your pressure switch effectively, which then feeds the compressor. Now the compressor takes a huge current draw on switch on, and even when it's running, it's still pulling 20, 30, 40 amps. It's pulling a lot of current. Because it's switching on and off the whole time the car's driving, as the air suspension changes in height and the compressor needs to run to fill the tank, then that's why I specified a solid state relay, because I knew it would be able to cope endlessly without actually wearing out its contacts. Another really good use for a solid state relay is when you are using what's called pulse width modulation. Oh my gosh, what's that? Well, I cover it in more detail in another video, but in short, what it means is you're switching the load on and off very, very fast, say 100 times a second or even 1,000 times a second, but the proportion of on time to off time is varying. So the average voltage going to the load is also varying. Now, a lot of programmable management ECUs, for example, have got outputs that can be mapped to have different pulse width modulation outputs. In other words, to control the speed of a fan or a pump or something like that. But often those outputs can't handle the current. The ECU doesn't have enough current capability to switch that load in a pulse width modulation way. So we can actually pulse width modulate an electronic relay and solid state relay that then actually runs the load. Here's another one too, another use you can make of a solid state relay. And that is, if we want to, for example, have a delayed on period. So we turn on the relay, back to using a switch, but when we turn off the switch, we want it to stay on for a little bit longer. What we can do is we can put a capacitor across like that. Now, a capacitor is a little device that charges up and stores electrical power for a short period of time, and when the switch is closed, because it's across the input like that, it gets charged up. When we open the switch, the capacitor keeps running the solid state relay for a little while, 5 seconds or 7 seconds or something like that. So it's a really easy way of adding a delayed on time just by adding a single electrical component. It's because the relay takes such little power to run it, the capacitor can keep it switched on for a while. Solid state relays, they're not very expensive and they've come down in price a lot over the last few years. If you're switching big loads frequently, or if you want to pulse width modulate a load and the ECU doesn't have an output that can handle that current, solid state relays can achieve all of those things. And here's a little bonus, you can also have that delayed on time if you're using a manual or a pressure switch or something of that sort. It's all in the book. The book's called Car Electrical and Electronic Systems, and I recommend it to you. Thank you.